The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The webinar will begin shortly. Please remain on the line. The broadcast is now starting. All attendees are in listen-only mode.
Okay, so anyway, so this, all that means is it's live. Right now it's live on the webinar, so anybody who's watching this webinar will be able to see it. And it's on, whatever. So it's recorded now, but we'll just cut off. There's this whole beginning part of nothing, but at least it's going. So basically, you just go, it's 5:30, we're just gonna talk. So that's it. Yes, because then they will be able to hear you. In Edmonton. Yeah. So it's really just me. Like I'm gonna talk on my microphone. I'm gonna be on my screen. You know what I should do? I'm gonna email my presentation thing to you. You can do it.
Yeah, we have Conrad.
Yeah.
Yeah. So we're in the big museum. So they gave us the welcome news.
Come on, you.
Okay.
Okay. Yeah. Watch them up.
So we have all of our sponsors. So next year we're doing a different format of sponsorship. So you guys will have the MRO conference in October. It's my annual. So we have our sponsored by Hotspot. Best MRO conference. It's pretty big. It's 2 days. There's a workshop and then there's conference pieces and everything else. So, yeah. Yeah, you want to it's like walking around the laptop after a hard day. But yeah, we want to get the live guys out. There's live guys, reliability guys. Yeah, right. There is nothing for live guys, but I mean, we have the reliability portion to the MRI conference. I was already had all just wrapped today. Yeah. These guys, so he goes 87. Yeah, there's a hard three down the middle. Yeah, so we could over one oil and gas lines. So we could over working. Yeah. And I really that we bought dry can. That's your guy, right? I don't know. Here's a story. Valor.
I didn't get the ball and my into the snowboard and my cartwheels over it. And as I was cartwheeling, I went, no, it's not. And then I grabbed my glove, that was this. I held my arm, skateboarded down, and they're looking for I was full of adrenaline. I was going down, and I'm like, oh man, now I'm on the floor. I don't want to. I know. One last thing, walking across, elbow, over it on the shoulder, right? I'm more and more moving towards being you know what? Really helps you really Wi-Fi system. Do you know when it's in the I got this right now. No problem. It's a long so now so glad it's stereo one. I keep it I smell that. I smell yeah, he's going to get the like so totally like that. My ears come this far away from the big. And then when I place it, alright, when I do, now I'm also trying to steer down today.
The show was okay though, but I mean, it's more obviously. Well, not as much for me, but I mean, I went up there to meet with Snowden anyway, so. You like me? You're a Jason Phoenix guy. So I thought no, I already had it. Oh Yes, today, World Show, Formac, Roy, I know. If I can get this one big enough, we'll walk into Turbo Show.
For the Emerald, right? Yeah.
Hey, Jared, can you guys hear us in Edmonton? Hello, Sherwood Park. Can you hear us over there? We're going to start in 3 minutes. I don't think they hear us.
No, it's that you're definitely hearing. I think they're choosing not to hear us.
They're choosing not to hear us. Okay. Hey, Jared, can you hear us at all? I think you can. You can hear me, right? I think he said yes. I see a thumbs up.
Yeah, I can hear you. Do you want to give take your seats kind of now, like 2-minute warning here, or what?
Yeah. 2-minute warning.
Okay.
I see you know, always sharing and always
Next year, the new logo. Where you at?
Yes, funny, we're getting our trucks wrapped, you guys. So it's like, it's on you. More.
Hey, Steve.
Sit down.
All right, Short Park, are you with us? Look, they're eating already. Are they?
No, we're not eating.
Okay. Hey, I see a lot of people there. That's awesome.
Yeah, we probably.
Okay, well, you can kind of see me there.
We got 30.
I'm gonna sit over. I'm gonna stand back here. I just won't look at the screen. Well, anyways, I see a lot of people here in Calgary. There's a lot of people there in Short Park. So thanks very much for coming out. We're gonna have. There's a little bit of feedback going on.
Ask them
Where's
to
that
turn
from?
off their
Oh, is that your guys' mic?
microphones on.
Okay, maybe.
Hey, Jared, can you mute the mic on your end?
Yeah, I'll mute.
All right.
Andrew,
So,
do you
anyways,
do you just want to do the MRO and all those kind of announcements then? Just you want to do
Sure.
it all? Sure. Yeah, you just do it. You do it. You got the mic.
all right. Yeah, I'll do it all. No problem. Yeah, so I think everybody knows now about the MRO, Maintenance Reliability Operations Technical Conference and Workshops. I don't know if anybody hasn't heard about it, but that's going to happen on October 26th, 27th. And so first day, half day workshops on various topics. You can go check it out. Available for CPD credits, but really just $250 or half days. So not bad. It's going to be, good for people that want to learn a little bit about something different. Maybe some younger people at your various plants. spread the word, get this out to, I'd appreciate if you guys, share the word over to your technical training people, whoever's involved with that, so they can make that accessible, and the managers, they need to know that it's something that can be attended as well. Second day, we're going to have a free conference, 1-hour presentations of various topics. We've got a keynote in the midday and a trade show as well from 12, trade show and lunch, 12 to 2. So that'll be a good time to see all the local vendors, local service providers, manufacturers, a lot of our sponsors, and some that are not our sponsors will also be presenting there. So people have always told me that they seem to get a lot of value out of the trade show because it's very applicable to everybody in the room. Well, yeah, so I'd really appreciate if everybody spread the word a little bit. Don't wait too long to register. That's for the Thursday, so that's on our website. And yeah, that's about it, I guess. We had a really good golf tournament, and that was the last time we saw some Rats people. I guess we did that in Edmonton. A good turnout. There's some pictures I posted. And I just want to mention too that a lot of the money that we get from the trade show that comes in, we put money back into sponsorships. So scholarships, sorry. So we've got 2 scholarships that go to University of Alberta. We got 2 for Red Deer College, Red Deer Polytechnic now, and also NATE. So they choose the awardees, I guess. So anyways, that's something that we do over there. And so as of today, we've got Nelson, I'm sorry, not Nelson Chan. I have a friend named Nelson, Kelvin Chan. So he's been with Dodge for over 7 years, 3 years in industrial distribution. He's solved a lot of problems, saved a lot of money, increased uptime for a lot of end users. Spent 20 years in manufacturing in different roles, design as well, management and sales. So he's got effective communication skills. I guess we'll put that to the test. And a desire to educate. So that is it. I'll let Kelvin take over, and he can kind of switch the screen over, and then basically we will get started, and then we'll do a bit of a Q&A at the end, and then we'll have food served. And Edmonton is free to ask questions as well.
All right, good to go.
You're good.
Thank you very much, Andrew. Thank you everyone for this opportunity to share this information with you. As my profile said, I like to educate. I love sharing information. So what we're going to talk about this evening is our ISAF spherical roller bearing. And at the very beginning of any presentations that I have, I always like to ask this question: why? Why do we exist? Why do we do this? Dodge is here to exceed customer expectations. And how do we do it? We do it by problem solving and by innovation. In fact, we've been doing this for about 140 plus years. In that time span, there's a bit of a delay, I guess. In that time span, we've designed, manufactured, and supplied mechanical power transmission products all around the globe. And what we pride ourselves on is it's having feature-rich, high quality and long lasting products. Oh, we're gonna have some fun tonight. Bear with us for a second. Bear with us for a second here. Okay. Yeah. All right, that's better. That's better. Yeah, sure. I think it's on. It's on. So this is who we are, and one important factor that really has to be stressed in the last few years is we're North American manufacturing. In fact, a lot of our plants in the U.S. are within about a 2-hour driving radius. So that allows the plants to share knowledge, to be able to share equipment, And the majority of our products are sourced in the United States as well. So there's very few components that we have to put on a ship and bring it into the US. So in the past couple of years, that has meant a lot. It's allowed us to be able to be really prepared for some of the logistics issues that have occurred in the past couple of years. So we really take pride in the fact that we are a North American manufacturer. The other thing that we want to do is innovate. And this is another core belief that we have. We're always trying to improve products, yes, but we're also improving systems and ultimately offerings for our customers. And the goal again is our customers. We want them to perform at the highest level possible. A couple of the innovations that we've had over 140 plus years time span, Dodge created the first split wood pulley back in the late 1800s. And then in the late 1930s, we created the taper lock bushing. You see this in every sort of belt drive application throughout North America and around the world. So it's a really familiar product. In the late 40s, we created a shaft mount gear reducer. And on into the 60s, we created a rubber tire coupling, one of the first rubber tire couplings. And not to sit on our laurels, you know, we make a product, we introduce it, but we continue to improve it. So in the 1970s, the gearbox that we introduced in the 1940s, we created a twin tapered bushing locking mechanism. So it allows you to take the shaft off really easily or install it. And then in the late 90s, we developed, Dodge in-house developed a new locking device for bearings, and it was the Imperial lock. And that's what we're going to talk about tonight. In the past decade, we'll say we've introduced other products focusing on specific industries like the food and bev industry, requiring higher demand for safety and cleanliness. And we've even improved on our Imperial bearing that we came up with in the late 1990s by making the safety mount. And again, we're going to talk about that this evening as well. And not to say that Dodge is completely all a mechanical company. We've dedicated resources to producing our smart sensor, which is a condition monitoring device. And that's our entry into the Industry 4.0 sphere. So our spherical ISAF, what is it all about? Throughout your facilities, you'll see a fairly common bearing. It's called the SAF. It comes in multiple pieces. It's assembled on site. There's a lot of interchangeable parts with many different manufacturers, so it makes it easily accessible to the masses. But Dodge, we found a different way of approaching the same problem. So with the SAF, the ISAF, it's the same footprint, so it's drop-in. We've introduced that Imperial adapter shaft mount to it. We have a full range of shaft sizes that we can work with. And the difference in the product is it's insert based or cartridge based. We're going to get into that a little bit later on here. So I'm going to present 5 really good reasons that you would actually consider the ISAF mounted bearing. Here's one of them. Do you think lubrication is really important for rotating equipment? Is it important?
Yes.
Yeah, absolutely, right? So here's the thing, with our SAF, ISAF style bearings, these already come factory filled with grease. It's ready to go. As opposed to typical SAF bearings, which, as you see in the picture here, you're looking at having to pack the grease manually on site. So, you know, what's the first thing that you think is going to happen to this thing? So we've seen this graphic before, I'm sure of it. The majority of premature bearing failures, it's 80% of it is lubrication based, right? It's old, it's wrong, there's not enough, you name it, a solid liquid contamination. How do you mitigate that? How do you make sure that that doesn't happen? There's 3 things you should be doing. Number 1, don't introduce it in the first place. Number 2, after you install it, you want to prevent contamination from getting it, right? And third, you should have some way of actually purging eventually what's going to happen inside that bearing. Contamination is going to enter, especially if the material is really fine. It's an eventuality. So how do you get rid of that? Well, is this the environment that you work in? Does this look familiar? Maybe a little bit of an exaggeration, but not necessarily in some places. You have an open bearing you're working with here. So you're packing grease in that environment. What do you think is happening? You're introducing contamination from day one. Now, wouldn't you rather have something that just ships completely sealed, ready to go from the factory? And that's what the ISAF is. How do we do that? Well, we want to not introduce contamination. Number one, here's the other step. We want to prevent contamination after installation. So how every bearing manufacturer lives and dies by their seals. And this is Dodge's approach. It's a triple lip seal plus a flinger. So that basically means 4 barriers of protection that restricts contamination from getting in. And in addition, there are other options for seals as well. But with this particular design, what we're trying to create is a grease dam. So you have these 4 barriers of protection plus the grease that you're gonna pack in here, right? So you really have the 5th protection is that grease dam. So you want to make sure that grease dam is clean, right? So now what's that 3rd thing that we have to do to prevent contamination? You got to find some way of actually purging this. So how do we do that? Well, in this graphic, you're going to see the difference between an SAF and ISAF in the fact that how contamination gets in or gets out. So in a traditional SAF, what you're looking at here is the housing of an SAF. There's a massive cavity on either side of that bearing inside there. So when you're pumping in fresh grease, it's a shell game. You're actually just moving the contamination over into this cavity. And then to add a little bit more pain, those LER seals are grooved. So you're moving more contamination into the groove now. So as you can imagine, how much contamination are you actually pushing out of this particular type of bearing? Now, compare that with our ISAF. So it's insert base. When you purge grease, you notice the shape of those seals are fairly unique. It's a one-way street here. We're pushing grease, it goes out with the contamination, and everything that's going with that grease is purged out. And that's what we want to do to properly maintain the life of that bearing. So how is it that we can do this? Because as you can see in this picture, you can see that grease being purged out. It's rotating. That's pressurized. We're actually using some means of pressure to actually push that out. And normally with a lot of bearing seals, you apply pressure to any seal and it's popping out. That is traditional seal design. Why does this happen with Dodge and that seal is staying intact? It's not popping out. Why is that? It's because the seals are mechanically retained. So no human hand is actually touching that to insert that into the housing. It's a robot that does that. It pinches the seal so that you can apply whatever normal pressure that you would, a grease gun, an auto lubrication system, whatever it is, you're pushing that grease out with its contamination. You're getting that fresh grease, and you're getting that grease dam, that fresh grease dam as well. So those are 3 things that are related to lubrication that really restrict contamination with our design. Oh, by the way, well, let's talk about how much grease you're going to use. The factory knows how much grease fills that insert, and they're going to get exactly the right amount all the time, right? So in the field, when that bearing, that SAF bearing is open, what are you doing with the grease? So you're buying 5 times the grease to actually pack this thing in that exposed contamination-based environment. And the funny thing is, I would hope the first thing that you do after you pack all that grease with all that crap is you're purging it out. Does anybody do that? That's not the first step. So realistically, I mean, you could be spending 10 times as much grease to actually make sure that you're doing it right. So what other things should you consider an ISAF for? Well, it's one part number, right? This is an example. Dodge makes SAF bearings as well, absolutely. These are our part numbers. Notice there's multiple part numbers versus the one part number. So here's the interesting about the SAF bearings. Remember I said that they're global. Any manufacturer makes SAF bearing parts, but you don't necessarily know who that manufacturer is. There's no way of knowing their quality control. There's no way of you knowing exactly where that comes from. When that panic happens in your plant and you're scrambling for these parts, you will work with anything you want, right? Or anything you can get your hands on, right? So you're going to get a mishmash of all sorts of different manufacturers. So there's an inherent risk in doing that, where you can't be confident necessarily in all the components that you're choosing to be part of this bearing assembly. What's another good reason? How about this? It's easy to install. You guys know what feeler gauges are? How many of you have actually worked with feeler gauges? Yeah? You have a skill set. If you've worked with feeler gauges, you have a very particular skill set. And it's an absolute rarity to know how to do this effectively, properly, right? So ISAF bearings, no feeler gauges. You don't have to stick those feeler gauges in here. I'll show you how to take the clearance out of these things. This is the steps. There's 4 steps to making sure that you take out clearance, check the clearance, etc., etc. And these 4 steps, you may have to repeat them, right? If you don't get that clearance out, you're going to have to repeat this, right? And as the bore, the shaft size gets larger, it gets a little bit more difficult to do this process. You require more people, you require more time, right? So how do you install a Dodge ISAF? Turn something clockwise. That's it. That's all you're doing. In fact, you're hand tightening it to a 0 reference. And then I have a chart that tells you whatever diameter it is, you put it through a couple more turns, either with a spanner wrench that has leverage or a hammer and drift. That's how you mount it. No feeler gauges. This actually takes the clearance out, sets it for you perfectly. And how does that happen? Well, if you focus on the blue wedge there, so when you hand turn it, I don't know if the graphic's going to work for me today, but when you hand turn it, oh yes, it moves, right? It pushes. And then when you use that spanner wrench or hammer and drift, you're locking it into place. Oh, see what happens? Okay, we'll back it up here. So what happens is it pulls. So that's why we call this a push-pull adapter. That effectively sets the clearance for you. You don't have to worry about feeler gauges. Another good reason. Well, just as easy as it is to mount, it's easy to dismount as well. With traditional SAF bearings, there's a challenge. There's a real challenge with dismounting these bearings. So how do we do it with our ISAFs? Counterclockwise, same process. This is one way to remove an SAF bearing. Don't know if the sound will go through, but so how many of you have actually seen that before? Yes? Winner. Yeah, you may have done this yourself. What in a facility, what does this require? You're going to need some sort of permitting, right? This is hot work, right? You're going to need time. You're probably going to need a new shaft after you do this, right? So look, with the ISAF, this isn't how you dismount. This is a lot easier to work with, right? Here's another nice little video you can see. Have you seen this? That's too painful to watch completely. So we'll just cut it short there. This is another way of unlocking that adapter from that shaft, right? That's usually the first resort before you take that torch out. Another good reason I'm going to share with you. Last one. This is about misalignment. So with the ISAFs, there is plus or minus 1 degree of misalignment. We all live in a perfect world of no such thing as a misalignment, right? Right. So when you're working with an SAF style, there is no capability for that seal to handle that misalignment. So what the difference is with the ISAF is that seal is contacting 100% all the time, and it's an inserter cartridge that moves with the shaft. So does the seal. It's moving with the whole insert. So that's where that misalignment capability comes about, right? With an SAF, you can go a little bit off kilter. Now you're depending on the seal to deform in a way that it was never designed to handle misalignment. So that can be dangerous, right? You go too far and that seal just opens up, right? Here's a success story that we had in an asphalt plant. So the application was a dryer. They were using an 110 millimeter SAF. We have a dirty environment, of course. This particular design needed a different type of seal, which does the same thing as what we have with that triple lip seal. It just handles higher speeds and the temperature as well. It's application based, so if you've got questions about that, we can talk about it after. But in this particular case, there was a 12-month life cycle for this bearing. And what did that cost? It's 40 euro per ton, which works out to about 4,800 euro per hour. What did ISAF do for them? So they doubled their previous life. That means 24 months plus. And of course, they prevented any sort of unplanned downtime because they weren't sure when within that 12-month cycle that SAF bearing was going to fail. That's where good condition monitoring works, right? So is there a way that we could improve this design? Why would we need to? Would we really need to? This is the third core principle that Dodge has. We make high quality products, yes, but we want to do it in the safest possible manner. If we can increase the safety level of that product as you're installing it, we will find the way. And this is what we did, because even, remember our buddy here with the torch? Even with our locking mechanism, the Imperial locking mechanism, what's going to happen is that you are still using a hammer and drift, right? Or a large spanner wrench, and that can be dangerous too, right? You're causing a potential sparking or whatever you're doing when you're actually hammering the locking mechanism down. So there's an inherent risk as well, just like an SAF. So what we've done at Dodge is find something that was faster, easier, but also safer. And lo and behold, we're just using hex caps now. No spanner wrench, no hammer and drift. And so basically it's tightening and loosening hex caps. So it's the same SAF footprint. It's the same replaceable insert. It's the same seal system that we're using, except instead of having to deal with now that hammer and drift or spanner wrench or any sort of blows, what you're working with is a hex cap system. So these ship with these hex caps attached. So what you're doing is you're basically hand tightening it, just like our normal Imperial adapters. You're marking alignment, then you loosen the hex cap bolts. But you notice it's an integral nut. So you're basically moving it to the other side of the slot, and then you're tightening it after that using torque. So it's a really simple system. And when you're dealing with diameters of like 4 and 15/16 to 7 inches, it's not massive, but it's still a good size. You need a lot of leverage or a lot of hammer blows to turn that locking mechanism. So This safety mount does it a lot easier, safer, and to dismount, you're doing the opposite. You're removing the hex head bolts, but we also have jack screws. So you're disengaging the external nut from the internal nut. Makes it a lot much easier. And we're giving you an assistance here to actually help out with that. So this definitely is about safety to ensure that no one's getting hurt at the end of the day. Can we improve on that? Okay, what happens if you're dealing with a shaft diameter of 7 inches to like 15 inches? How do you deal with something that large? There's some pretty serious work to be done on that. This is why we introduced the hydraulic ISAF. So, same idea, except hydraulic pistons is what we're using. So you're hooking this up to a power pack to disengage the locking mechanism or engage the locking mechanism, whichever you're doing. So the safety mount, this hydraulic ISAF, they're all the same in the fact that there's no feeler gauges again, right? They're replaceable inserts. That limits your critical spares. You don't have to have the whole block sitting on a shelf. Now all you would need is the actual insert. So that reduces, ultimately reduces your costs and reduces your inventory. Here's a really nice success story from CSX. This is a loadout facility in Toledo. It's an iron ore loadout facility. So they were using SAFs, and the installation time was 48 hours. You can imagine that. And they had challenges, setting clearance, bearing failures, things like that. And how did they actually solve it? Well, you know what? I'm just going to bounce out of here because this is one of those success stories that I like to read. I'm going to read verbatim what this Ron Davenport said about this installation. He said, keeping the bearing from being contaminated in the outdoors is nearly impossible. Would you agree with that? A bearing changeout never seems to happen on a nice day. It's usually raining or snowing, and that makes it tough on the team. Plus, you really have to know what you are doing, especially understanding how to set the tolerances just right. We spent a solid 48 hours changing out that bearing. Not only is it a fight to get a fail bearing off, but the bearing also destroyed the shaft. So it had to be changed out as well. That's when I seriously began considering using the Dodge hydraulic ISAF bearing because I knew there had to be a better way. And just maybe this was it. Oops. There we go. Sorry. So those were his words, not mine. It's printed, published. I read verbatim what he said. And this is his conclusion here. It says, believe me, installing a bearing has never gone as smoothly as this. So what have they been able to do with this bearing? So remember 48 hours, right? 48 hours to install this thing. They cut it down to 4 hours. So that's cut by 12. Did it work? Yeah, they moved 3 million tons of ore already with this bearing in place. It worked. So just a quick summary, why would you consider ISAFs? Well, it's one package, not 100 different part numbers. It's factory sealed. You cannot introduce contamination into this system. The cost of grease, the amount of grease that you're using would be excessive for the SAF versus the ISAF. The factory knows how much to put in it perfectly. And the seal, the actual seal system is really what shines in this because it's purgeable. It prevents and it allows you to refresh as well. And the big thing here, feeler gauges, no more feeler gauges. So that being said, it's easier to install and easier to remove. So any questions? Yeah, go for it.
Coming from a reliability standpoint of having these in storage, what is the life expectancy to have it on a shelf before use? Do you need to do preservation to avoid vernelling? as well as the grease component inside of it? When did it start to break down, or can you just simply purge it?
This is my lawyer in case I was going to incriminate myself with this presentation, but Cameron here, he's our product specialist. So some of the finer details he gets into.
Hello, I'm a jack of all trades, and what I don't know, well, I can fill the Titanic. Oh, I can see my ugly face. Yeah, hello, no, I didn't break her, and we're not ugly enough yet. To answer Steve's question there, just had an example here with Timberland out west there. We had a hydraulic bearing that had been on the shelf for 5 years. I worked with the product specialists. Don't want for reboard Brunelling. They're good for 7 years on the shelf to keep us spares. And yes, as Kelvin described in the presentation, 100% purgeable. Prefer it when it's running.
I got one more question because I love doing bombs and CMMS, so this hits home for me for many different reasons. Are they rebuildable? Is this something you would send back to the States? Is it economical? Because I know the cost of the housing is probably the most expensive part in some of the larger bearings. Is it economical to have them rebuilt? Do you rebuild them, or do you recommend just a replacement?
So I can actually answer that question, Steve. Do you have a robot that can actually pinch the seal into the housing so it becomes purgeable?
We can.
That is the difference. For us to rebuild,
There's a certain cost involved in it.
so the thing is, how much does it cost to actually ship one of these things down to the United States? It could be quite excessive. That's one of the limiting factors when we talk about rebuild. In the US, we have rebuild centers for all sorts of our product, but it's just not economically feasible to offer that all around the world, right? Or even in Canada here. And
Kelvin saved you so much money.
yeah,
Big oil, thank you later for saving the money, I'm sure.
absolutely. Cool, thank you. Does anyone in the audience in Edmonton have a question, or?
The volume hasn't been working the whole time. I'm gonna start all over. No, we're good.
So Jared, you got any questions up there in Edmonton? No, got a quiet room there? How about anyone here in Calgary? Does anyone got more questions?
Comments, any reliability between clean service, like you're making clean service, you may take the dirty service out of it, how do they compare to SAF?
You measure that.
I don't know, MTR or MTBR? Yes.
Yeah, that's a good question.
If you're in clean service, what's the benefit of moving over to that?
Install time. The human factor.
Yeah.
Again, like Kelvin had mentioned earlier there, like it's only as good as the person installing it. And what happens is we remove the human factor, right? You on your best day, we're not questioning you. We're not questioning a millwright or a professional, right? That's doing it well. But again, we're talking about the guy in clean service and ideal conditions. You still have that human factor. This removes that human factor and the differentiator parts. Even if you're buying 100% SKF parts, are they date coded? Are the parts matched, right? Are the housings matched, right? And again, does that become A1 critical? I guess it could if we're going to needle it down to write things there. But we're talking about guys where we see the real benefit there. You're going to see it in the lab at a smaller extent. The larger extent is when the guy's in the field and it's 5 o'clock in the morning, the guy's hungover, right? He's sitting there like, huh,
Who told you?
yeah, fucking feel it. Oh, feel it. Feel it. Oh. It's that, right? Yep. Exactly, right? Sorry?
Edmonton doesn't hear what.
Ah, that's right. Yes, sorry. I guess we're kind of answering questions into the universe. It's just, I guess the original questions here is about lab install versus field install. And now, sorry, your last question there again.
What can go wrong with the install? Like, what's going on if you're overtight, or run up, just on a drift, are you looking at the same thing?
You're going to see heat. You're going to see heat, and you're going to see that heat spike, right? Right, and in critical equipment there, it's going to be monitored, right? So you're going to see that initial heat. Yeah, so you are removing the human factor of initial install, grease pack, and contaminant and all that kind of stuff. But also, yeah, if you're not following instruction manuals, just like there is a certain aspect of limiting the amount of instructions, like I said, limiting the human factor. You're not eliminating it, of course. People will, there's always an idiot that'll find a way to screw something up no matter how simple you make it, right? Don't underestimate stupid people because they're out to get you. But that's what keeps us in business. We love stupid people.
Here, here.
Right. I'm one of them. All right, unless there's any other questions there, I think, are we good?
All right, I think that's it. Okay, yes, one question.
Let's run to the back.
Yes, yes, yes.
You mentioned that a regular bearing will, the part of your presentation where you described about purging a bearing with grease, and would you fill a bearing with 5 tubes of grease, and will you purge that bearing of the used grease that's in there? A normal bearing, if you're not able to purge a normal bearing with grease, it'll blow out the seals, and that'll tear your bearing apart. So there's no purging a bearing of grease if there's no purging capability. So that's something that I learned today. I don't know how that functions, but it's interesting that you can purge a bearing with grease, because normally in that application, you just blow out your seals. And when you do that, the dirt gets in and your bearing's done.
Yeah. And to your point, like again, back to the presentation there, like Kelvin on the slides, I know it was a bit of a quick presentation. Like I said, the grease is going to go through, like in our triple tech seals, or you have your 3 points of contact with the fourth being the external flinger. So the bearing, the way the seals are designed is the grease is going to pass through them and travel through, creating a grease dam and force its way out. Being mechanically retained, like Kelvin mentioned, these things are pinched in there. They're done robotically. Kelvin and I have both been to the plants there to do it. So it's a consistent process, right? So they're pinched in there. They reverse it. There are some slides that we could have put in here where they did destructive testing, whether it's on our ball bearing units, which weren't featured here, but on our spherical units, which are featured here. These guys went to extraordinary measures. Like our in-house application engineering team went through extraordinary measures, and they have, I don't want to quote the PSI that they put these things through, but it's beyond what the average mechanic's going to do. Like, I don't know, like someone's going to have like mobile equipment hooked up to a grease gun and forcing it through at 7,000 pounds. Like, it's not, again, your average grease gun's not going to do it, but don't underestimate stupid people. Yeah, you're right. I kind of said that earlier, but that's one of the benefits of our housed units, right? Like traditional SAF bearings there, especially if you're using like a rubber lip contact seal on them. I think SKF is like a TSN. Ours own is going to be like a version of our triple tech. The housing's retaining it, right? And if enough pressure, that's going to push that thing right off the housing. A labyrinth seal, again, it doesn't allow for any kind of deflection and that. So yeah, that's definitely one of the featured benefits of having a cartridge unit with Dodge, right? And it allows it. And static purging is good. You're going to see it statically. We prefer to have it running. Even if you fill the cavity 100% when it's static, when you fire that thing up, again, you're going to have a temperature spike. It's going to purge. The temperature is going to come back down, and it's going to be fine. Okay?
Thank you.
I've got a question, if I may, besides Scott. Mike Greer with Spartan. A lot of my business is around condition monitoring and the transmissibility of energy around the rolling elements and the outside carcass. So with the complexity and the diversity of advanced technologies, has there been any correlation studies about health and complexity of the various systems there when we come down to bearing mounting for health purposes?
Yeah, like our application engineering team, and as I mentioned, I'm not even a salesman, I'm just a product specialist, but our application engineering team, if we need an in-depth analysis, they have it. There's going to be white papers and engineering papers that are available to comment on that, right? As far as your question goes there, unfortunately.
Yeah, so like what a lot of people are now, it's all the big wireless buzz, right? And then
yep.
It's all around this other layer of 3-axial monitoring and that. Have you found any difference when people are implementing these advanced technologies? Have you seen any variances, or who would we contact if we wanted to know the impacts of this?
Myself or Kelvin can be contacted, and like I mentioned, our application engineering team that will have that data if available, and that's just a matter of reaching out and getting that. I haven't had firsthand experience with it. I know they have, like I mentioned before, lots of white papers, lots of in-depth studying, and they have a lot, like our application engineering team and our facilities we test in-house quite extensively. And that data, if available, can be made available to you as well there. And we also, like, as you mentioned, condition monitoring, we have our smart sensor program as well.
Plus, there's obviously a huge install base that can provide feedback.
Oh, yeah.
And now Mike is going to sing karaoke.
I would say there.
You got to throw some humor in it.
Who gave him a mic? There's I guess we can call it anecdotal evidence. And ultimately, in the end, what's the goal? It's to save money, right? If you prevented something from happening, you know, I've got a case where, like I showed, we have a condition monitoring device. We know our signatures for our bearings, you know, but what we have is more actionable. There's no interpretation required. It basically, hey, it's traffic light technology. It's simplified. So, you know, red, yellow, green. I mean, everybody knows what that means, right? So we've had a case, one particular case in Alberta. I can't name the company. It was in southern Alberta. They had an inaccessible location for a bearing. They had our smart sensor on there. It was a real pain in the butt to implement because limited Wi-Fi access, and it's Bluetooth technology, of course, right? So, you know, in this particular case, I mean, they prevented a fairly significant catastrophe, I guess we'll call it, right? And it was into the tens of thousands as far as what they saved in that incident, in that moment of time. Every plant has a different way of measuring how much their 1 minute is worth, right? So that's what it boils down to, right? And that's why condition monitoring is so essential, that you prevent that 1 minute, whatever the heck that costs you, and it's already bought itself, right? That condition monitoring system or program has already paid for itself in spades, right? But yeah, we can offer anecdotal, as in we've got a lot of implementations of our device that have, we go back and actually interview the company when it actually goes through that type of savings. It's one of our goals at Dodge is documented savings to prove that, you know, in this case, this is what happened. This is what their hour of time was worth. This is what it prevented, and we've got a number of those cases. But if you want like raw data.
I was just thinking about transmissibility of the energy from any condition change with the complexity of one system versus the other. Is there study? No, you're not just transmissibility of energy. Isolated bearing with that cartridge. It's not restricted ability to measure. It's like a lot of the sun is just going to be casing it.
Right.
So that's like,
so we're talking about accuracy now, right? Like.
Transmissibility.
Yeah. Okay.
It's gonna be very similar.
Yeah.
Right. If not the exact same, because we're running. So the bearings that are running in here. So we're using a different locking device, but we're also using like your traditional numbering system. Like if we're talking about double row spherical bearings, if you're familiar with that, like a 22217 KC3, that's what we're running in there. It's just a different locking device. So it's, if not, to comment directly on it, yeah, again, it gets we get the nerds on the phone, right? And I'm and away we go. But I guess kind of picking up what you're saying there, I'd say yes. No, it's the same. The outer race and the principle of the bearing, like we're talking about a different locking device. Inner races, outer races, rolling elements, cages, it's all going to be traditional. Same bearing frequencies, right? You're talking a triple deuce 17 Dodge is the same in an insert bearing with a different locking device is the same as a triple deuce SKF or a triple deuce 17 SKF as an example, right? And then by application basis, right? We look at things at an individual level. What's your application? What's your speed? What's your load? We'll tell you what it needs to do. Hopefully. It's priceless. They're within shouting distance. There is a bit of a premium to save that much amount of time, like in Kelvin's. So the question is being the time or cost savings between or pricing between traditional USAF and ISAF. There is a bit of a premium, right? And it's a case by case basis. And then you look at all the other factors, right? We give you how many wins, and we're not asking for day-night service. Are we talking a price differential? It depends. If we're going to average things, because it all depends on the customer, depends on the scenario. It's roughly a 15% premium, possibly over it, but that is going to vary. It's not very much. Like Buddy saving in Kelvin's example that he read off there, what, like cuts time by 12, 48 hours down to 4, and then you got, regardless, you got a couple of your strong buddies helping you lift this thing on the shaft, and then you can do it all by yourself. Our example with Timberland out in Ontario there, his buddies abandoned him. It was an 8.5-inch bearing, and Buddy, I didn't see him. He must have been pretty big. Like, he's like, hey, yo, I got this bearing. I'm going to put it on here. It's lifted. Yeah, I took the rides this morning. Away we go. And he did it all by himself, right? And then he's calling me and the other product specialist up, and he's got the video up there, and he didn't have a guy to hold the phone. He's putting the phone down. He's holding the phone up. We're like, oh yeah, spin it that way, do this, right? Because on a hydraulic ISAF is what it was. You got to have the adjusting nut or the mount nut fully on, and then you got to have the removal nut out of the way because you can't push it on if there's something in the way. So we're telling him, yeah, do this, do that, and he's putting the phone down. Hey, yo. I never seen the guy, but he must have been big because that bearing weighed 300 pounds. I don't even know how he got it on the shaft. Like, it's like, holy smokes. His buddies must have just like went and ran for lunch or whatever it was. But all right, well, I can do voices on. I'm not only here for my good looks.
Thanks, Rocky.
Right on.
All right. Well, I think we can probably finish on a high note and a high laugh. Want to thank both you gentlemen from Dodge Bearing, everyone in Calgary and Edmonton. Let's give them a little hand here for taking their time out today and present. You know, just when you think you know everything about a bearing, we've seen 100 different things, but you know, there's a lot of things that I didn't even know or options that you had. So that was pretty informative that I see value in many different applications, parts reduction being a huge thing with SCM these days. So yeah, I think this was a great turnout. Thank you guys for your time. Thanks everyone for joining today. Andrew, do you have any closing remarks? So, all right, well, hey, we got the MRO coming up next. So definitely be sure to register online, share within your communities, at work, customers, whatever it may be. I think it's going to be a really great turnout coming out of COVID. I think we needed this. So everybody have a great night, get home safe, and we'll see you next time. Thank you.